For the notes in section 6.5, now that we've learned to multiply radicals, we're going to solve equations with radicals. And the first thing that you need to do is solve for the radical. That radical needs to be all by itself, one side of the equal sign. So, isolate the radical. Then, you are going to square both sides. This is for square roots. If you have a cube root, you'll cube it. If you have a fourth root, you'll fourth it. So get the idea. And then we are going to solve for the variable, whatever that is. Well, I was going to call it x today. Now, in some of your problems, in order to solve for x, I'm going to put an extra thing here. You may need to factor. And our last example is going to cover that. And then the last thing you need to do is check. Make sure your answer makes sense and doesn't give you a non-real number. Okay, we've got 3 examples here, and we're going to start with example 1. Okay, our radical is already solved for, so we're going to start immediately with the squaring both sides. So when you square a square root, all that's left is what's under the radical. And we're accustomed to solving problems like this, so x is 5. Now, the last step says that you need to check, and you really do need to check it. Whether you write it down or just do it in your calculator, you really need to check it. So is this equal to 3? Square root of 9 is equal to 3. So that one is checked and done, and this is our answer. Okay, example 2. We have a cube root, so that means we'll have to cube to get the x out from under the radical, but our radical is not isolated, and it needs to be isolated, and we're going to start with that by adding 1 to both sides. Alright, so our radical is still not isolated because it has a 2 multiplied by it. So we need to multiply, actually divide by 2, which gives us the cube root of x is equal to 2. So since we have a cube root, the way you undo a cube root is by raising it to that power. So we have x is equal to 8, and that's our answer. So again, before we know for sure, we need to check and make sure that we're not going to get a non-real answer. So substitute it into the original equation. That's 2 times 2 minus 1. Is that equal to 3? 4 minus 1 is equal to 3. So that one is checked and done, and our solution is 8. Last example. Okay, our radical is not isolated. It has a 3 subtracted, so I'm going to add 3 to both sides, which gives me 8x plus 24 is equal to x plus 3. Okay, now, here's where it's different. That whole factoring thing. When we square both sides, we're going to need to FOIL x plus 3 and x plus 3. Remember, that is not equal to x squared plus 9. That's wrong. So don't even go there. So when we square this, what is left is just what's under the radical. And when we FOIL x plus 3 and x plus 3, we get x squared plus 6x plus 9. Now let's pay attention to what just happened here. We have gotten a square. That square means that we need to set our equation equal to 0 and factor. So we need to subtract 8x and 24 on both sides. And what this leaves us with is 0 is equal to x squared minus 2x minus 15. And then we're going to factor. And I know that factors of 15 that are 2 apart are 3 and 5. And that this one needs to be negative and that one needs to be positive. So x is equal to negative 3 or x is equal to 5. So we need to check this answer. And we're going to go back to our original equation, which is the square root of 8x plus 24 minus 3 is equal to x. So we're going to start with checking the x is equal to negative 3 first. So 8 times negative 3 plus 24 minus 3, is that equal to negative 3? Because we have to substitute in this x also. So negative 24 plus 24 is 0. So that's 0 minus 3, and that is equal to negative 3, so that one checks. So we need to check the 5. So we have 8 times 5 plus 24 minus 3, is that equal to 5? So 40 plus 24, square root of 64, minus 3, is that equal to 5? And what we have is 8 minus 3 is equal to 5, and it checks. So we have two answers, negative 3 and 5. So don't forget to factor if that's what it's asking for.